Usually spending nearly $8,700 gets you, a decent used car, four wheels, an engine, maybe even a working radio.
Out if you're lucky, yeah.
Right. You definitely don't expect it to buy a single white robotic camera. So welcome to this deep dive. Our mission for you today is unpacking exactly what makes the Bolin Technology EXU420 and NW 4K60 outdoor PTZ camera actually worth that massive price tag.
It's definitely a sticker shock if you're just looking at the number, but to really understand the value, you have to look at how this camera merges extreme physical durability with ultra-high-definition broadcast tech.
Like a tank with a 4K lens.
Exactly. On the outside, it carries an IP67 weatherproof rating, which basically means it's an armored shell built to survive torrential downpours. And inside, it's packing a Sony 4K sensor and a heavy-duty 20x optical zoom.
Okay, an IP67 armored shell is great. But if the lens is covered in freezing rain and the stadium lights are glaring, physical brawn doesn't really matter if the image itself is just garbage, right?
Yeah, the picture's useless.
So how does this camera actually see and adjust in those chaotic outdoor conditions?
Well, that comes down to the AI-powered facial analytics engine. It works directly with that Sony 4K sensor. You see, standard broadcast cameras usually measure the light of the whole scene.
Which is why a bright sky or like a harsh stadium strobe makes the subject's face go completely dark.
Spot on. But this AI engine creates a real-time depth map instead. It instantly isolates the human face from the background glare.
Wait, instantly?
Yeah, frame by frame. It independently adjusts the exposure and focus just for the subject.
Okay, but let's unpack this for a second. Broadcast crews have had human operators handling focus and aperture in the rain for decades.
True.
Why do we suddenly need to outsource that to an AI at this massive price point? I mean, is the AI actually faster than a trained cameraman?
In unpredictable conditions, absolutely. Because the sensor is pulling in massive amounts of high-resolution data, the AI is calculating adjustments at a speed a human simply can't match.
Especially when their fingers are freezing out there.
Exactly. The camera essentially thinks for itself. It maintains perfect lighting on a moving subject without a human riding the controls.
So we've eliminated the cameraman's frozen fingers, but all that perfectly exposed 4K data is kind of useless if it's trapped inside a camera out in a blizzard.
Right. It has to go somewhere.
Yeah, it has to feed into complex live production systems.
And this is where its software protocols really shine. Specifically, something called the Freed protocol.
Freed. Like F-R-E-D.
Yes. Think of Freed as a spatial tracking language. It provides the exact axis data, the pan, tilt, and zoom coordinates.
Oh, so virtual studios like augmented reality sports graphics or weather maps can perfectly sync up with real-world camera movement.
You got it. And it pushes all this data out using a feature called True Tri-Output.
True tri-output. Let me guess, it's not just splitting a signal, is it?
Not at all.
Is it like a chef cooking the exact same meal simultaneously for a fine dining critic, a fast casual diner, and a takeout order, perfectly timing all three without breaking a sweat?
That is a brilliant way to frame it. It is actively processing and outputting 3 independent streams simultaneously.
3 streams at once. Wow.
Yep. First, an HDMI feed to a local monitor right there on set. Second, a heavy-duty, uncompressed SDI feed routed straight to the live broadcast truck.
And the third?
An NDI IP stream over the network. So a producer in another country can access the footage instantly.
That is a serious amount of processing power running flawlessly in a rainstorm.
It really is.
I mean, it's bridging this massive gap between an unpredictable, messy outdoor environment and an ultra-low latency, perfectly synchronized virtual reality studio setup somewhere else entirely.
Exactly. Ultimately, this Bolin camera isn't just a lens attached to a sensor. It acts as a rugged, AI-driven data hub for modern broadcasting. It takes on the worst elements so the production team doesn't have to.
Which leaves you, the listener, with an interesting thought to mull over. Because if we now have cameras that can use AI to perfectly track faces, adjust for chaotic lighting frame by frame, and automate precise VR movements right in the middle of extreme weather,
Right.
what does the future hold for human camera operators in unpredictable live broadcast environments?
It really makes you wonder. The camera has basically become the ultimate autonomous operator.
Yeah.
Maybe the next time you're watching a live outdoor broadcast, you shouldn't just be looking at the picture.
No.
No, you should be asking yourself who or what is actually behind the lens.